Good evening, ma'am. Okay, we'll start for the day session, so you can take over, please.
Sure, ma'am. Thank you so much. So, good evening, everyone. Welcome to our day 11 of this series of lectures. Right. So, good evening, everyone. So, let us start the session. Let me share my screen. So, yeah, before going into the session, if you have, anyone has any, question for me, yeah, good evening. So, everyone. Good evening, Om Prakash. So you can just ask me, maybe we can take just a couple of minutes. So if you have any question in particular, you can just let me know. Actually, one thing, let me share the. So I just share the dataset link. You can just download and keep. I think no one has any questions. Okay, fine. So let me. Fine. So if you don't have anything, we can start. Okay, fine. So let us start the session. Okay, let me share my screen. Okay. So let us talk about one of the very important concepts today. Let me share my screen now. Okay. Right. So I hope you can see my screen. Yeah. Fine. Okay. Great. Right. So let us today talk about one of the very important algorithms in data science and analytics field, which is the XGBoost. Okay, so I'm not, briefly I'll explain about what is first of all boosting, and why, what is gradient descent first, and what is exactly gradient boosting, and then why we are using this extreme gradient boosting, and what role does this extreme gradient boost actually play a important role, or how does it contribute to the machine learning aspect. Okay, so before going into what exactly is XGBoost, let us first let us understand that what is gradient descent also. So gradient descent basically is an algorithm where we have something called as a just give me a minute. Huh. So we have something called as gradients. Okay. So, I'll keep it very simple. Okay. I'll keep it very simple in explaining what is gradient, uh, you know, what is gradient descent, and what is exactly the role and all. Okay. And based on that, we can, identify and try to understand. So, if we have to understand what is exactly gradient descent is, there is something called as a gradient first and then a descent. So, gradient is nothing but a word which is gives you or which actually tells you about the steep. That means, if you see a hill, right? So the going up or the upper point, right? That is basically called as a gradient. And if you say gradient descent, that means you are looking at a point which is the steepest point, which is downwards, or you can say the point which is downwards, right? So that is called as basically the descent. Okay. So this gradient descent algorithm was, or I can say gradient descent function, right, was actually initially founded or which was invented actually by Augustin Louis Cauchy. Okay, so this person, Augustin Louis Cauchy, is a French mathematician, and you wouldn't believe, right? This function was actually invented by Cauchy in the year 1847. So now you can imagine, right? I'm just calculating also. So this is around some 177 years old function or mathematical function which we are using now in our artificial intelligence. So now you can link it was really mind boggling when I have when I first came to know a few years ago, and how the function which is built around some 177 years ago, that is actually contributing for doing classification, particularly in this era of AI. So that's how the people imagination and the knowledge used to be there. So right. So coming leaving about that aspect, coming into our concept. So from that gradient descent, the concept which is actually I'll not go much into mathematical stuff and all, because it is completely mathematical, like downright. So because yeah, you can imagine why XGBoost also becomes a pure mathematical concept, because the founder of gradient descent is actually a pure mathematician. Okay, so he has a lot of research, and he has done a lot of things in particularly concepts like real analysis and all. So, leaving that apart, so how this gradient descent actually transformed into gradient boosting, right? And how this boosting algorithm has actually transformed into XGBoost, or you can say extreme gradient boost. Okay, actually, a gradient descent itself is very strong. After that, gradient boosting has even more, or you can say even more strong, or even more, it has more strength. And this extreme gradient boosting has extreme strength. That is why they name it justifies the word extreme, so to that a title also. So coming to the concept, basically what exactly happens in gradient descent, I'll tell you. So you would have known the concept of in linear regression, right? A simple linear regression like beta naught plus beta 1x, right? We know that there is something called as a slope, right? We have already understood, and even in our sessions we have learned the concept of slope as well. So basically, what is slope? Slope is nothing but the rate of change. Okay, so I'll keep it very simple, very, very simple, please. Okay, so that even person who doesn't have the mathematical knowledge also will try to understand. So how do you calculate this slope? Is we are calculating in a statistical way, right? Many of you know the statistical way, but that is not the way actually it is calculated, or it is how it started. I will say it is calculated in a statistical way. It is correct, but there is there is a foundation for that, which is the partial derivatives. So this partial derivative is the concept where has come into the existence, where it all started, the concept of gradient descent. So this is the actual picture. So it is based upon few things. like the partial derivative, right? And and there is something called as a cost function. So already we know what is a cost function. So cost function is nothing but the whether it's a minimization or a maximization problem, and the error function is nothing but the difference between the actual and the predicted value. Now, so coming to this gradient descent part, right? So there is one more important thing, right? So why we are focused on the value, or the down part or the descent value, which is the down part, right? So why we are focused is actually there's a concept called convergence. So we want ideally the function to be convergent function, right? So to a lowest minimum possible value is what convergence actually is. So we try to match, or we try to, send our function, or we try to make our function to a convergent value or a convergent, particular point, so that we can ideally predict the value correctly. So this is how it all started actually as a gradient descent. So and there are some of some more concepts like the local minima, local maxima, right? And so based upon the learning, there's something called as a learning function. So learning function basically we use that learning function even in neural networks. So we'll see neural networks in the coming maybe tomorrow we can start the neural networks once we finish the time series. So we apply this, the learning rate function, and then we have after that we are going to build on the cost function, right? So on. So there are many aspects of something called as a saddle point, vanishing gradient. So like this, there are many small concepts which you can do some research maybe later if you're more interested to learn about the gradient descent. So why I'm speaking about all this thing is, why all these things are required here to understand is, this is the basic basis for the XGBoost. Okay, so what is this gradient descent and all? Now, coming to the what is a boost? First, before starting XGBoost, let us go to our let us go to our PPT or our project. First, we'll try to understand from there. Okay, so this is what a main, this is a very good image which will give you some understanding. Okay, so basically, what is a decision tree? We have already learned. So basically, what is a decision tree? It is a tree-based structure, right? So first of all, you can remember that even our gradient algorithms are also particularly tree-based algorithms, particularly like the XGBoost. Now, so decision tree, and we also have understood that there are some limitations in decision tree. And decision tree is a very good algorithm, but there are some limitations when it comes to decision trees. So this has been rectified by using the concept of random forest, right? So that also we have seen how random forest plays a very vital role, and how random forest is actually, I can say, how this random forest is actually playing a very important role as as using the concept of bagging, right? And using the functions of decision trees as well. So basically the concept of bagging and decision tree together is what random forest basically is, right? So that also we already know. Now what is happening, what is the need for employing, or what is the need for using an ensemble technique, which is called as the boosting part. Now, right? So why this boosting is basically used? So what happens when it comes to boosting? So boosting is basically an algorithm or a technique, right? So which is basically used for weak learners, right? So combining multiple weak learners is basically what is boosting is. So in a very simple term, you can remember that the boosting is basically combining weak learners. So what actually this boosting tries to do is, it will try to minimize the loss function. Okay, or loss functions you can remember. We have already have gone through. For example, like the mean square error, right? That is one loss function. And we have one more, which is the what is it? Cross entropy or cross entropy. So that is one more loss function. What we have actually learned as well. So you know, based what this is trying to do actually, what this boosting is actually trying to do. So what this is actually trying to do is this gradient boosting or boosting algorithms are basically using the mechanism of gradient descent first. That is the reason I've told what is a gradient descent. Okay, maybe I've not gone very deep. Okay, because if I start talking about gradient descent, if I have to explain, put up a PPT on gradient descent, that itself takes around 2 hours. Okay, so around maybe 1.5 hour or 2 hours. That much of very big concept. A gradient descent, again, in that we have again stochastic gradient descent, mini batch gradient descent. Like that we have again types of gradient descents. So we have to talk about each and every gradient descent. We have to understand, and then the implementation part, the mathematics behind it. So that is again a huge a huge session, right? And that's what not I'm not going to. This is not a complete mathematical session to teach all those formulas and concepts and all, right? So we are trying to implement an algorithm into machine learning, right? So this is what the sessions are about, right? So that is why just a little thought on what is gradient descent, and just to keep it in mind how it works. Okay, that is what. And from there you have the concepts of this gradient boosting. Okay, so boosting is basically building a sequential models. Okay, and sequential models and improving the weak learners. So now what happens if it so it basically uses the concept of boosting, and it basically uses the concept of gradient descent. So gradient descent plus boosting concept is what gradient boosting is. Okay, so this one you have to keep it in mind. So for everything the basis for particularly boosting concept, the basis is the gradient descent part. In this gradient descent part, it is combined with the concept of boosting. So boosting is nothing but building a sequential model. So in combining with boosting, it becomes gradient boosting. And if you apply, I can say extreme gradient boosting, where you can run parallelly, and and the tree can handle everything, and it runs very fast. It avoids overfitting, it avoids regularizations. It runs heavily for huge. It runs extreme. That is why extremely powerful. So that is the reason they have named it as XGBoost. So that is how this XGBoost name itself has come. So from slowly one name to the other name to the other. After that slowly upgradations, and slowly building slowly building the concept, and finally it became as a XGBoost. So this is the history and all those things of this gradient boost. XGBoost. And then before what is XGBoost, and as I already told you what is boosting. And so basically what this gradient boosting actually does is it both uses the concept. Actually, I don't want to touch this, but I just want to tell one more concept. There is something called as ADA boosting also. So what is this ADA boosting is adaptive boost. So this is basically tweaked to, it uses the concepts of errors and predecessors. So that is again, one more concept, because boosting actually has two things. One is gradient boosting and ADA boosting. Okay, let us not talk about ADA boosting. And when we talk about the concepts where it tries to learn in a sequential way. Okay, so you can just remember that gradient boost, in a simple way, not to complicate. It is learning which happens in a sequential way, right? And it combines basically the weak learners and builds into a strong algorithm. So that much you can remember when we talk about the gradient boost. That is what, that much only I wanted to tell you. Okay. And now let us come to, this is what the image is about. Okay. And okay. And let us just go to the bagging concept, right? Here also, if you see the bagging concept, right? We have seen bagging, particularly when we have done the when we have actually done it in the random forest, right? So whether it is boosting or whether it is bagging, basically it's an ensemble technique. and these basically combine the weak models, or you can say, multiple weak models and build it into an ensemble model. Fine. So we already know this concept, right? But what is different from the bagging to boosting? Boosting, we are using the sequential approach. So, in a sequential way, we are trying to, right? So at each step, what is the sequential? I've been talking and keep on talking about sequential and all, right? So what is exactly the sequential part is, just want to show you as well, okay? So what exactly is a sequential approach when it comes to the boosting models is, in a sequential approach, what happens is we try to correct each errors at the previous model, or you can say error correction is done, right? So that means when you are building some five models, you are combining some five models and building one ensemble technique. So, the first model, when the first model is built, the first model is perfect for what we want to do. We don't go with errors in the model and again construct the second model. So that we are not going to do. And if we have, we try to predict a very good model, that is why we are calling it as a sequential approach. That means one model, after that the other model, second model, then the second model to the third model, right? So like that, we go in a sequential way. And at each step, we try to fix any errors which are, maybe any misclassifications, right? Wrong predictions of any regression value. So we try to predict this, or sorry, we try to fix this, and then we are going to move to the other part of the model where we can, build. So finally, what happens if we, keep on correcting, and we keep on moving forward, right? So what happens eventually, the final outcome will be a very good outcome. So that mechanism, this boosting actually follows. So I can remember like this. So gradient descent, gradient boosting. First of all, yeah, gradient descent, boosting, gradient boosting, and extreme gradient boosting. So this is what the order, and this is what the, so you can see this in the image. Okay, so gradient boosting also I've actually mentioned. Okay, just go back to what actually I'm talking about. XGBoost and all. Okay, so what exactly is a gradient boost? So gradient boost is basically an algorithm which is used for regression and classification. So by this time you would have understood that what exactly the mechanism of, using this gradient boosting, all right, on the basis of gradient descent. So gradient boosting is a machine learning algorithm which is used for both classification and regression, and it is in the form of a weak prediction models. So typically like a decision tree. So it builds a model stage wise, and yeah, stage wise is nothing but the in a sequential way. So, and it is basically using the MSE, which is the loss function, right? So mean square error. So after that, we have something called as a learning rate. Okay. So in the learning rate, we call learning rate as an alpha. So how much of adaptation and learning the model is actually trying to do, right? So basically, we go with the learning rate of 0.001. Okay, so yeah, even in deep learning, we take the same kind of learning rate as well. Okay, yeah. Now let us try to understand. I think here one important thing I just wanted to discuss. Um, so this points let us discuss. Okay, and then we'll go to the what is the gradient boosted trees and all. Okay, so basically we are trying to update the predictions, and we are trying to sum all our predictions, which is the minimum close to zero, or you can say that the what our predicted value and what is the actual value. We are trying to reduce the gap, and the actual and the predicted value are almost similar. We are trying to do that, okay, by using this models. So what happens is the weakness in some other model is actually fixed, and that will be rectified also, corrected here, or maybe it is corrected in the other model based upon the criteria and the way the algorithm actually builds. Okay, right. So now let us see what is the gradient boosted trees. Okay, so gradient boosted trees are a special case of decision trees, and okay, so here you can see there is one, I can say one image. Okay, so here you can see that people have age, gender, and occupation, right? And we have built a model. right? And here you can see in the decision tree that if a person's age is less than 15, right? If it is a yes and a no case, you can see that if it is a yes, whether that person is less than, sorry, if the person is male, then he's going to like the computer games. And if that particular person is a female, that is, he's not a male, so definitely the girl doesn't like the computer games. And definitely, if the age is not less than 15, definitely you're not going to like the computer games, right? So based on that, we are going to build a decision tree. It's a very small example which I found interesting to show you. Okay, so you can just go through this tree part and all later. Okay, right. Now, as we have already have discussed, you can see this partial derivative function, right? So we are going to use this particular functions. So one thing to tell you, right? No need to, as I already told you this, no need to by heart any formulas and know any formulas. Just to have an understanding that what is this algorithm about and how it works. So that maybe you can just try to understand, because you're not going to apply any formula, right? So already the algorithms have their built-in formulas. Okay. Now, right. So now let us go to the XGBoost. Okay. So here I have mentioned a few things. So basically, XGBoost is called as an extreme gradient boost, and this is a which is actually originally written in C++ language. After that, it is also written in Python, and compared to the other ensemble languages, XGBoost is extremely fast. Okay. Now, basically, this tree-based have actually evolved a lot when it comes to the evolution of these tree-based algorithms like the decision tree or random forest. And this XGBoost also belongs to the family of the tree-based. Okay, so that is what small thing which I wanted to come back. And what are the main features of XGBoost? So there are some of the important aspects to understand what happens in XGBoost. So the main reasons we should know this algorithm, that it is very accurate, efficient, and it is very feasible. And it is basically a linear model, and it is actually trying to use a tree-based method, and it does parallel computations, or it does this parallel processing, right? Which can be done, and the way it actually handles the data is what so it uses more GPUs, right? The graphic processing units to perform the calculations. So it also has extra features for doing cross validations and computing feature importance. So there are some added benefits in XGBoost. So it is capable of, I can say, you can think of like, it is little more uh, smart. Okay. So the main features are, very three important features are sparsity, customization, and the D matrix. So what is sparsity basically is, it is the it is basically using the tree boosters and the linear boosters. So boost, again, you can think of the boosting techniques, what happens in boost and all, I already told you. So customization is, it has more objective functions and evaluation functions which are available inside the XGBoost. And then we have the D matrix, which actually gives you the data structure, which is for more performance and efficiency, right? And yeah, difference between bagging and boosting, I think we have already have discussed. Okay, this ensemble technique is itself the concept of uniting or bringing in both the strong learners and the weak learners together, right? And particularly weak learners to make into strong learners, right? And in bagging, it is an approach which is done together. Weak learners, we are going to merge, and we are going to get the ensemble method. In boosting, we are not going to merge like that. We are going in a sequential way, and then we are going to build an ensemble technique. That's the only difference. Apart from that, both are ensemble techniques, and both give a very good result. So based on scenarios and situations, we can use whichever kind we want to use. Okay, so here see. So for boost, see bagging, what is happening? Just a small again. Just I'll explain very briefly. So all the for all the samples, we are building a weak learners, and for these weak learners, we'll combine it and make it as a ensemble technique. For boosting, what is happening? We are building that for the data set. We are building a weak learner. Okay, and for that weak learner, a weak model or weak learner, and on that we are getting one answer, and that answer will be updated in the data set based on the answer what we are getting, and the data set will be changed little, right? Manipulations and all those things are done, and then based on that again you will build a weak model and the final result. Like that we'll be converging into like that we'll be using multiple sequential approach till we approach our so what is this data set? The second part is not using the initial data set, right? It is using the updated results. So little modifications. Maybe this is 70% good. This will become some 75% good. After that, some next one might become some 83% good or 80% good. So like that, it will keep on updating and then it is going to build. So that is what a boosting is about. Fine. So let me go to the next part, which is talking about the extreme gradient boost. Okay. Fine. Now here, if you see, what is happening here in XGBoost, right? So we have seen that what is the build-up for all this, extreme gradient boosting, and on what mechanism this boosting concepts actually work, right? So let us also understand what happens particularly in a gradient boost now. So this is one of the fastest implementation or fastest algorithms which can be processed, because see, always remember, that is why if you see, why deep learning has become famous, because deep learning actually uses the GPUs, not the CPUs, right? So it uses the GPUs, the graphic cards, right, to process the data for parallel computations. That is why, we have, that CUDA cores, right, the processing units, execution units. So those who are aware of this technology, you can remember companies like AMD and NVIDIA, right? So NVIDIA makes graphic cards based on this CUDA cores and processing units and execution units and all. So those who are aware of these particular concepts might be little understanding, because these algorithms which are based upon GPUs uses those GPUs particularly to process the to parallelly process and have that computational power. Okay, so that is why particularly people suggest to use maybe a graphic card laptops, or a graphic card built desktops for particularly processing of data analytics and data analytics and data science particularly in that again particularly machine learning. No, machine learning is somewhat fine when you go to deep learning, right? So it is little more more GPU centric. Okay, so that is what in that that particular area, or that particular that particular loop comes this XGBoost also. So that is what remember this one thing, whatever algorithms uses the GPUs are more faster than your regular algorithms which use the CPUs. Okay, so this one line you can remember, so you will understand based on automatically if you're saying if you read that algorithm or learn about an algorithm, and if they say the algorithm is using GPUs for faster computation, obviously you can understand that it will be a faster algorithm compared to the other algorithms which use the CPU for processing. Fine. So now to process this fastly, it uses the gradient boosted trees. Okay, so based upon the samples, it is going to split the data, and fastly it is going to calculate. And one more important thing is XGBoost tackles this inefficiency. If we consider the potential loss for all splits to create a new branch, we have thousands of potential splits and losses. So to handle this, what happens is this inefficiency when we are splitting the data and potential losses. So by looking at the distribution of features across all data points in a leaf and using this information to reduce the search space of the possible. So all the XGBoost implements few regularizations and all. It actually has that I can say in a very simple language. Okay, let us if we read, we might not understand, some of the things. So I'll keep it, I'll tell you in a very simple language. So we can say that, it is capable of handling the issues. For example, like the hyperparametric tuning, regularization, overfitting problem. So we can handle all these things with ease without any problems in XGBoost. That is what the the I can say the conclusion of what I've mentioned. So it is able to handle these problems, right, without much of loss, right? Maximum, it tries to minimize the loss function. So this is what the main agenda of using the XGBoost. So right, so let us go to the implementation part. So before that, if you have any questions, you can ask me. Okay, so you can download this dataset, wholesale customer data. Okay, so let me delete this before I have put this not required. Maybe you know what is all those things. Yeah, okay. So you can download the data set, just maybe a couple of minutes I can give you. In that meanwhile, maybe we can take questions also if you have any questions. Um, so if you don't have any, some 2-3 minutes after, I'll just start with the practical part. In the meanwhile, you can download the data set and you have questions also, you can ask. So both the things you can cover it off. So yes. One more thing, one more thing I just wanted to tell. I've actually explained about gradient descent, gradient boost, and what is XGBoost in a very because of the time constraint. I've kept it very simple. I don't know how much you're able to understand also from what I told, because I can prepare 100 pages PPT just on gradient descent. Okay, so that much of big concept, right? A lot of formulas and a lot of things are there. Explaining the concept, how the implementation part and all that much of concepts are there. So I would recommend to just do your investigation part on the gradient descent and gradient boosting and XGBoost. Okay, so I'm keeping it very simple just for the because of the time constraint. So that is one thing I just wanted to tell you. So maybe you can ask me any question if you have. Yes, absolutely. I think I've not used that word. That's why. Yeah, Om Prakash is asking me gradient descent is an optimization technique. Yes, it is an optimization technique. Yes. Yeah. So this gradient descent, what happens is it starts from scratch. So if I have to, I'll tell you in a very simple way. It starts from scratch. Randomly, it selects a point. It tries to find the local minima or maxima based upon the kind of approach we are making. So it is like this. I'll give you a very small example of gradient descent. Okay, not without pushing too much. For example, right? You're at the top of a hill. Okay, so if you want to go down the hill, right? If you want to go down the hill, for example, you are going in a particular route. Maybe you have lost that particular route, right? And you are kind of lost. So you don't have any GPS or you don't have any. So it creates U shape. Correct, sir. Yes, from the from the top part it comes down, which is the minimum point. There you can reach the minimum point. Yes, it is exactly the U shape. Absolutely correct. Yes. So yeah, you kind of lost. You're going down. You don't have any GPS, and you're kind of lost, and you have to go down the hill. Okay. So what is the next best thing you will do? Right. So whichever way or whatever way you know, you just go down. Correct, because you want to go to down of the hill, right? So maybe if you have lost the way or you don't have the GPS to go which direction, right? But you know that to reach the bottom of the hill you have to go down, right? So gradient descent is exactly that. You go down arbitrarily, right, to reach the point which is down the hill. That we call in mathematical terminology as convergent point. The minimization point of that particular hill is called as the descent point, or the down point of the hill. In mathematics we call it as a convergent point. That means the least possible value of that particular function where that function converges is called as a convergent point. On this principle gradient descent works. That's why I just mentioned also it's a pure mathematical concept, uses the partial derivatives and the calculus. It's a combination of partial derivatives and calculus. On that gradient descent, it is merged with boosting concept, which gives you gradient boosting, and it is merged, and it is even recreated and more with more innovation into technology as extreme gradient boost. That is how, that is why I told it's 170 years of journey of gradient descent to extreme gradient boost. So I think this was invented maybe some 20-30 years ago. So it's 140 to 50 years of journey, right? So yeah, it has evolved from it has taken different, and it has evolved. So yeah. So anything else? Okay, I think no questions. I think I can go ahead. Yes. Fine. All right. So let us see the data set. I think I've already shared with you, and I hope you have downloaded. One very important thing is usually your machine learning algorithms or deep learning algorithms will be mostly inside your sklearn or your TensorFlow and Keras. PCA is different, sir, completely. PCA is used for dimensionality reduction. No, student or faculty, Prakash. Okay. So it is PCA is different. It is used to reduce the dimension in the data. So it is basically a dimensionality reduction technique. This gradient descent is an optimization algorithm. They are completely different, sir. Completely, two sides. You can't actually put them together. Okay. So right. So either TensorFlow or Keras, or you might see this in XGlearn. But what is different in XGBoost basically is this XGBoost actually lies in the you know a library called XGBoost. Okay, so all small letters XGBoost. So from XGBoost, you have to sorry, yeah, you have to. It's a free free source library only, right? So if you just install pip install XGBoost, automatically it will be installed in your Jupyter notebook. So if you are using Google Colab, no need to install also, because automatically in the cloud you will have the the XGBoost which is already there. So from XGBoost, we are importing the XGBoost classifier. Okay. So other things I'm not going to tell. And from XGBoost, we are using the CV. Okay. And let us go down to the data set. Okay. So for XGBoost, I've taken a very simple data set. Okay. Because it's a very heavy algorithm. Okay. It's very fast, but it's a very heavy algorithm. So here what I'm trying to do is I'm actually taken the data set, which is the wholesale customers. Okay. So what is this data set is basically what is this basically data set is about is so right. So what exactly this data set actually tells you is there are some attributes or features in the data set, right? So this data set will give you the different things like the channel, region, right? And fresh milk, grocery, frozen, detergent, paper, and delicacy. Okay. So what is this delicacy basically is this delicacy is actually the annual spending. Okay. So okay. So this is basically based upon the annual spending. Okay. And this delicacy actually offers, for example, it's I can say, even it's a very actually a word which we would have never heard, because this word is actually a German word. Okay. And yeah, it's a German word for you can say fine food. Okay. So for a fine food. So this delicacy is basically a store where they sell these sandwiches, food, and all these things. Okay. So the what they are trying to, yeah. Okay. Oh, right. So channel here variably actually contains one or two here, and this one or two indicates that the customers are basically from this retail customers, or they are from hotel, retail, or cafe customers. So whether they are nominal customers or whether they are the customers from this other three parts, which is the hotel, retail, or cafe. So that is what the data set is basically about, right? So now let us go to the information or info about the data set. Okay. And you can see that there are no null values. Okay. It's a very small data set, and no null values and all. Okay. So here what the describe function gives you the we already know what's the describe function, right? So we have seen it in the before algorithms as well. So this describe function basically tells you about the standard deviation, mean value, right? Quartiles, maximum value, minimum value, and all those things. Going down, if we check for the null values, obviously there will be no null values, right? And we have to predict the channel. Okay, let us go directly to the algorithm. Okay. So we have to predict the channel, right? So what we are doing is we are dropping the channel from the x value, which is the independent variable, right? And we are giving this channel. That means predicting which kind of customer he is. Okay. So that we are giving to the y, which is the dependent variable or the target variable. And we have print the head of the customer. You can see that there are head of the X value, you can see that region fresh milk, this channel has been dropped, right? And if you see the head of this, you can see that it contains all the, whatever under channel are there. Okay. Now, for actually our channels are basically our values are on 2, 1 and all, right? And we do one small modification here. Where y is equal to 2, we are giving 0, and where y is equal to 1, we are giving as 1. Okay, we are doing this small modification. Once we try to allocate this value, obviously the values have changed from 2 to 0 and from 1 to 1. 1 becomes, 1 will stay as 1, and the 2 has actually, the 2 has actually become 0. Now, let us go to the next part of the data, right? Now, let us apply this D matrix. Okay, so this is basically an optimized data structure. Okay, you can see it here. So it is an optimized implementation, or an optimized way of implementing the XGBoost. Okay, and this is basically used to give high performance and give good efficiency as well. Right. So now let us implement the the uh, D matrix, okay, in the XGBoost, because this D matrix is in the XGBoost. Okay, and let us define XGBoost for this labels X and Y. Okay, now let us go to the next part, which is splitting the data into 4 parameters: X train, X test, Y train, and Y test. Okay, and we are testing, we are splitting it into training and testing part for X and Y. And then we are giving the test size as 0.3. So if we give the test size as 0.3, that indicates that the training, the training part is around 70%, right? So training is basically 70%, and the testing part is around 0. Or I can say 30% of the data. So next is we are training the classifier now. Okay, right. So now what we are going to do is we are going to use So now what we are going to do is we are going to give the objective function as the logistic regression. Okay, because it's a binary classification. So since it's a binary classification, we are giving the using the binary function, which is the logistic here. Okay, and maximum depth, params is nothing but the parameters. Okay, so maximum depth is around 4, and the learning rate we have given 1. Okay, so we have given the faster learning rate because it's an XGBoost. Okay, and the number of estimators is basically 100. So once we train this using the XG classifier or XGB classifier, so this will train the algorithm, or you can say train by building the model. Okay, so now you can see that it has classified, right, and it has taken some of the things what we have actually mentioned. So we need not worry about this one. The only thing, the parameters what we want to give, either we have given it or not. So the parameters what we want to give, and the classifier, right, what we want to give, right, we are using the XGB classifier, right, extreme gradient boosting classifier. Then we give the X train and Y train to classify. Then going down, you can see that the classifier has actually trained the model. Okay. After the model is trained, we test the score. Okay. First of all, we try to make the predictions first. So on the X testing, we try to predict the values. Okay. So once we try to predict the values, you can check the model accuracy using the XGBoost function, which is the accuracy score for the Y test and the Y predicted value. Okay. So once this is done, you can see that the model accuracy, okay, is around 87%. You can change this. Sorry for this. Okay. And if we go down, okay, we can see that there is k-fold cross validation using the XGBoost. Okay. Now we'll try to implement with the k-fold cross validations. This k-fold cross validations are basically these use the CV method. Okay, grid search CV algorithm. Okay, so this is basically where it will keep one. If it builds into 5 parts, it keeps 1 part for testing and 4 parts on training. So that is what this k-fold cross validation is. I think in previous algorithms also we have seen. So now let us implement this XGBoost algorithm also by using this grid search CV method also. Okay, so here you can see that these are the parameters which are actually used for training the grid search CV, right? And the first parameter is basically the n folds. So this parameter actually specifies the number of cross validation sets we want to build. So here, how many we want, we can give. Okay, so in the n folds, and then we have the number of boost round where it denotes the number of trees we want to build. How much of trees you want to build, that also we can actually give. Then the metrics. So usually we use the metrics or the performance metrics or evaluation metrics, which we can, which checks or which will test the, which will test the classifier how well it is performing. So next is the using the as underscore pandas. This basically gives your results in the data frame. This usually gives the outcome as a data frame. So next is early stopping rounds. So this basically early stoppings are used to identify that the model doesn't overfit or underfit. So for this we are going to use this early stopping rounds. So next is seeding. This parameter is basically used for reproducibility. Now let us build the using the XGBoost using the grid search CV algorithm. So we are using the CV, which is the grid search CV, and let us see what is the head of the algorithm. Once we applied for these parameters, we have applied the CV. Okay, and here we have given the dtrain as data matrix, which we have mentioned before. Okay, here we are using the CV function. So now the values have actually changed, right, based on how the grid search CV actually applies. So these are different values which we cannot understand much, but this values are nothing but the based upon the AUC, which is the standard deviation, and the mean values. Okay, so it denotes the AUC is nothing but the area under the curve. Okay, and it denotes the values for the mean and standard deviation for training and testing. That is what these values are. Now, let us see the feature importance when it comes to the XGBoost. So here, when it comes to the XGBoost, it is very important that we analyze every feature within the model, right? And when we talk about the splitting part and how do we visualize and all those things, plotting is very important when it comes to the visualization, particularly thing called as an XGBoost, right? So now let us do the feature importance or feature selections on the kind of the features what we have actually given. So now if we give the importance, right, the when we create a plot using the XGBoost and we give the feature importance what we want, it shows whatever features are extremely important, which contribute to the target variable or the outcome variable. Okay, right. So now you can see that for on what things this particular features play a very important role. All right. Now, so in this, small thing, right, what we have actually understood is what are the important factors which are actually contributing to the outcome. So in the grid search CV, it has showed that this detergent paper and frozen plays a very important role, which contributes more to the outcome variable, right? So that is what the project is basically about. So building the models around some 87%, I think we got the model's accuracy actually is about. Okay, so that is the about this particular project. So if you have any doubts on this, you can just ask me. I've taken a very simple project actually to explain XGBoost. I didn't wanted to take a very complicated project because particularly if you see projects on XGBoost, they are little highly complicated because the part where the implementation part is very high, and many of you would have not aware of the concepts of XGBoost and how this boosting algorithms work. So maybe if you want more from XGBoost, any particular more high level project, maybe we can discuss on one day if you just mention if you want any high level, we can do that as well. But I would feel this is enough for you to understand how XGBoost works. Okay, I kept it very simple. Okay, so this is what you can understand. So if you don't have any doubts, we'll start one more concept. I just wanted to uh, start one more concept as well. So just give you a couple of minutes. Maybe you can just let me know if you have any doubts. And that meanwhile, let me open the other project also. CV part. So CV part is nothing. It's about the grid search CV, sir. See, it is about using the CV model. So it is actually using this, I can say, cross-validation techniques. So K-fold cross-validations. So it basically uses that K-fold cross-validations. Actually, we have done it on our previous projects also. You can just refer that also. So the same way how these K-fold cross-validations work, the same way we can use this CV part also for the grid search CV part, which is a kind of a method, I would say, which uses the K-fold cross validations. So we are using this method for for implementation in the XGBoost also. It is a very similar way of implementing. It's a very similar way of implementing how we implement for the other algorithms. It's a very simple way. So just give the CV function and the parameters, whatever parameters we mention. For the params is nothing but the parameters. Okay. So just give me 1 minute. Let's share this also. I'm checking that. My NB file. Just share. Sorry. Just share this XGBoost project also. You can just download that. Just a minute. Huh. So let me start this time series project today. Okay. Let me share this. So I'll share the data set also. Just give me a minute. So I'll just start with the time series. So maybe we can continue it and we can finish it off tomorrow. About this LMS, you can ask Shushmita ma'am or Chandana ma'am, whoever is there in the session. You can ask them. Data set I've shared. You can just download that data set. Okay, so let me just give me a minute. I'll share the link also for reference. You can have this dataset link as well. Yeah, I'll share the link also. So I will share the link. I've shared the CSV file as well as I've shared the link. Okay. So let me start by let me start by first of all explaining about the time series and what we do in time series. Let us just try and figure it out. Okay. And we can, yeah, it's a very big project actually, time series one. Maybe we can continue it tomorrow and we can complete. Right. So let me share. Fine. So I've shared the dataset link also. You can just download that. We are using this struct sales. Okay. So while doing this project, I'll explain the concepts also. Okay. What is stationary, what is AR model, what is, moving average, all those things I'll explain when we are doing the project only. Okay. So that I'll do. We are learning that project part. Fine. So now let us start with the time series. First of all, what is exactly time series data, right? So in a very simple term, even I've mentioned the definition in a very simple way. If you think about what is exactly time series, right? So something which moves with the time, right? Something which moves with time, and where time plays a very important role, right? So, for example, sales, weekly sales, right? So, if I want to analyze weekly sales, their time is playing a very important role. So, wherever time plays an extremely important role, that kind of data is basically called as a time series data, right? And now, when we see the components, okay, so we see three particular things. One is the trend, right? One is the seasonality, and the other is the residual. Okay, so these are the very three important things when it comes to the time series data. Now, to keep it very simple to understand, what is this thing, what we are doing in the time series? I'll try to keep it very simple for you to understand. There are some models which we build. Okay. So, right from the very small part, if we talk about, right, it starts with the concept of moving average, or you can say maybe it starts with AR also. You can take MA or AR, anything is fine. It starts with that. So, what is this AR basically is? AR is nothing but an auto-regressive model. Okay. So, what is this auto-regressive model, right? So, we will understand that why, why we are using this auto-regressive model. Then there is one more separate particular concept which is called as moving averages, which is MA. So, right, that is one more second thing is. Based on this, there are a certain models which are built. The first important model is the ARMA model. ARMA includes autoregressive model and the moving average model. You can see it in the image. Okay. Now, that is one thing. Second thing is the ARIMA model, which is ARIMA. What happens in the ARIMA model is, what is the I? It is basically auto-regressive integrated moving average. Okay. So it is basically auto-regressive integrated moving average. That means you are also including the trend part. That I'll come to that when we build the model. Okay. Just for, just for basic understanding, try to understand this. So we use the integration part. That means you're integrating both the autoregressive or bringing together both the autoregressive and moving average by using a certain concept called as trend differencing. Right now, you remember that we use the trend in the ARIMA model. Then we have one more, which is the SARIMA model. SARIMA is bringing, S indicates the seasonality. Okay. So, seasonal changes, right? So we talk about the seasonal changes. For example, very small example I'll tell you. Sale of umbrellas are more in the rainy season. That is a seasonal change, right? You know, the sales of woolen garments are high in the winters. It's a seasonal change. That is what we are going to bring into the model for Sarima. Sarima is basically using both Arima and seasonality. That means we are bringing in autoregressive model, moving average model, trend differencing or understanding the trend, and we are also bringing in the seasonality. These three are extremely important models when it comes to the time series data. ARIMA, sorry, ARMA, ARIMA, SARIMA. These use the techniques called as AR and MA, which is autoregressive and moving averages. Right? So this is the very simple outer picture. When we, rather than me just explaining the whole time series things, because there are a lot of things to talk about in time series. So, when we start building one step after the other, so there itself, I'll try to explain that, why we are using this, what happens, what is the need for all those things. I'll try to explain. Okay. This is the basic introduction that what we are actually going to discuss in the project. Okay. So particularly for data, which is having, for example, like sales, which is, having, through the, which is use the time constraint, right? So for that kind of, so even I felt, a project on sales will be a better way for you also to learn the three big models in the time series. Now, let us go to the introduction part of what exactly is a time series. So we have understood that something which gives priority or something which is playing a very important role, right, in, predicting something where time is playing a very important role, that becomes a time series data. Now, where exactly we use the time? So I told sales, right? There is one more very good example which I have given here, which is the stock pricing. Stock pricing has time constraint as a very important factor, right? Yes. So you can use the times, or you can say stock pricing is basically a time series data. So something, like a temperature or a revenue, right? So all these particular values are actually falling into the, actually are falling into the category of regression models, correct? No, because if when we have already studied that if we have any numerical value and we predict, that becomes a regression problem, correct? No, so here what is happening, it is basically a regression problem, but we are using the time constraint as well, which is related. So the models are little different from what we have built in the regression. Okay. And this particular, we are going to build the AR, MA, ARMA, ARIMA, and SARIMA models, right? So you can understand in a very simple language that this is basically regression, but using the time constraints. So the models will become different, okay? And the most important thing also is I have mentioned here, see, time series regression differentiates from other regression models. There's a small difference between the regression model and the time series model because of its assumptions that data correlated over time and outcomes from the previous models can be used for predicting the outcomes of the subsequent groups. Okay, so I don't know how much you understood, but very simple way to tell here time is playing a very important role. So we have to keep time also in mind and we build a model. That's it. Like this much you can understand kind of right now. That means where time is also playing a very important role, not just the predicting the value just by building a regression model. That is not sufficient. We have to consider the time part and build a model based upon the time factor also. That brings the time series data, that brings your ARMA, ARIMA, and SARIMA models into the picture. This is the whole scenario. Now, let us predict the sales for forecast models. Let us build for the future 3 years, right? So let us move forward, right? So into the coding part, okay. Anyway, I told the concepts also. I will explain. When we talk about the right the concepts of stationary. Okay, so I'll tell you what is a stationary, what we have to do when the problems of stationary and how to use this to check the stationary. The very most important test is Dickey-Fuller test. Okay, so this actually tells you how the data is actually stationary. Right, without stationary, we cannot apply a time series model. So we have to make the data stationary. Like that, there are a lot of factors, and then like that we'll understand step by step, and we'll also build the models like this. Okay, so line by line I'll explain the concepts also, how to make it stationary, what happens with the lag and all. Little economics also comes into the picture when we build the time series models, because see what are autoregressive models, what we are using, what are moving average. So line by line we'll go as a process, right? And try to understand that what are the important things, what play a vital role, and how to identify certain things. Like I told you that how to make the data stationary, how to identify whether the data is non-stationary, right? Whether it is stationary or non-stationary, and how to make it stationary if there are some tests, right? And the most important and successful test is the Dickey-Fuller test. Okay, so that how we are using that and all we will try to learn. Okay, so anyway, not going to the model building now, we have less time today, so we'll continue this project tomorrow. But let us see what we are importing into the Python environment, right? So this all these things. The most important thing is you are using the stats models. Okay, so you have the stat models. So we have the things like the ARIMA models and the Dickey-Fuller test, which we will be implementing, or which will be importing from the stats models. Okay, so here you can also see that you have plotting and all, which can be built into. Okay. Okay. So these are some of the things which we'll be importing into the model. Now, this is the data set what we are trying to use. Okay, I think I've shared with you also, right? So I've shared the link to the data set as well as the data set itself. So we are trying to analyze the data, right? That is the truck sales. Okay. So we just printed the head of the data. We can see that the data has number of trucks sold and the the month and year of the data. Okay, so this is what we are going to do. Now, here if you see, that we are trying, the most important thing is because it's a time series data, right? What we are trying to do is we are going to split or we are going to import the calendar. Okay, because we need the month, right? And here you can see that it is month. Okay, and we know that the year is 2022 sales we have. Okay, and maybe the year is also there, right? We can take it. So yeah, here is mentioned, no? The range starts from 2003, right? So I think maybe some 20 years of data they might be having. So here you can see that we are trying to import the month part and we are trying to import the year part and then we are trying to import the day part as well. Okay, so we are importing the calendar, okay, to build all these things, and we are trying to build, see, in such a way that we are trying to segregate the month and year part. Okay, so since we have segregated the month and year part, we can see that we have dropped the original columns of month year and we have renamed it as month year, and this truck number of trucks underscores this sold also we have changed it to truck sales. Okay, so we have modified the columns. Now, if you see carefully when we plot the graph, okay, so when we plot the graph on the, by using the matplotlib and seaborn, what is happening is you can see a graph which is plotted over time. So this shows that what actually it shows is how, right, from year to year, how the sales actually vary of the number of trucks. So number of trucks sold, how many trucks have been sold. So through the course of time, right, the graph is actually shown. Okay. Now, once this is actually built, let us go to the right thing, that let us understand that we can observe that there is trend and multiple seasonality in the above graph. Okay, maybe you have not understood this sentence. Let us, come to what is the concept of stationary. Okay, maybe I'll tell you what is a stationary concept. Okay, and maybe here we can stop, and tomorrow we can apply this test, Dickey-Fuller test, to see the stationary part. Okay, fine. That should be fine. Now, let us see the concept of what is stationary first. So this basically comes from the word where the in a simple terms, I'll tell you what is stationary. Um, the over a period of time, okay, over a period of time, by a textbook definition, we say that if you have the constant uh, correlation, right, variance and the autocorrelation over time, right, so it actually goes in a smoother way, we say it's a stationary. Okay, so how to understand in a very simple language? So this actually, how we can understand in a very simple language is, stationary is something where, so for example, if the sales are going in a smoother trend, for example, the sales are going like this, okay, maybe they're going little up, okay, so like this they are going year after year, year after year, it's going very smoothly. So what happens, suddenly there is a lot of dip or there's a sudden spike, okay, and again it come down, right, and it is again going up, very much up, and again coming down, so there is a lot of abnormality, right? So that abnormality is called as non-stationary. That means the data is not constant over the time. Sir, why, if it is there, what is the problem? what is the problem is, if that is there, what actually happens is it is very difficult to predict the future. If the data is in a smoother way, that means a constant increase. For example, every year there's a 5% increase or a 10% increase, a sales. So it is easy to predict for the next 3 years or 5 years, right? Whatever it is, because this autocorrelation depends upon the concept of lag. Okay, so what is lag and all? I'll tell you. So this lag is basically the correlation between the present outcome and the previous outcome. That means the relationship between the present outcome with the previous outcome, right? Or the before stage, right? Or you can say, I'll tell you this. So for example, sales of a product today, right? So if it is dependent upon the previous day sales, then it becomes autocorrelation. That means the correlation is automatically created. That's why they have named it as autocorrelation. That means the relationship between your previous day sales is depending upon your today's sales. That is what correlation is. Okay, so I'll talk about lag. What is lag in autocorrelation, and how to prevent this lag, because lag is not a very good aspect when it comes to the this stationary and predicting this time series models and all. So I'll speak about that later. Okay, so why it is before I wind up the session, the small thing what we actually do is we apply a test called as a Dickey-Fuller test. So this will tell us that whether that particular data is actually stationary or it is non-stationary, and how to, this will actually identify that, stationary and non-stationary component. Okay, so that is about this Dickey-Fuller test and what is stationary. I'll just tell again about what is stationary and all, because it's a very important aspect before you understand, because I feel a little more detail into autocorrelation, what is lag in the data, and what is autocorrelation, and how stationary plays a very important role, what happens if it is non-stationary, and what is the relationship between applying this Dickey-Fuller test and applying this ARIMA, SARIMA, GARIMA models. Right, we have GARIMA also actually, but we are not implementing in this project. We are only applying the ARMA, ARIMA, and SARIMA. So how this play, all these things play a very important role in building our time series model, that we have to understand. So this initial part of lag autocorrelation is extremely important for you to understand. Even if we spend a little more time on that, it is okay. We have to understand. So in the next session, let us try to understand and continue the project of time series, and after that we'll go to the deep learning part. So Chandana ma'am, you can take over. If they have any doubts, they might, they can ask in the next session. It's already 9, so.
Yes, Shashank. Thank you.
Yes, ma'am.
Yeah, students, tomorrow we don't have a session. So again, we have session on Monday. Okay, please mark your attendance. And any more questions, you can ask me.
One student has asked, one student of they have asked about this LMS, ma'am. You can just check with them.
Oh, okay.
How to download and open in VS Code projects, which is an LMS, they're asking.
Yeah. So if you have any queries regarding LMS, just drop an email to edl@excelor.com. I'm dropping that mail in the chat. Okay, please take from here and drop a message. Okay, my team will clear that query. Okay, Shashank, I hope we are done. So we'll meet on Monday. Thank you.
Sure, ma'am. Yeah.